Okay. Sorry about that. Do you want me to go back and repeat all of it? I'll just, hopefully your notes will be clear and we'll come back to it. But marginal revenue is the derivative of what? This is key. This is key. You've got to know this for the test. Marginal revenue is the derivative of what function? Say it again. Revenue. Okay? So if I have marginal revenue as the integrand, the antiderivative is revenue. Okay. When I take the, if I'm looking at the marginal revenue from the first day of Christmas season to the 10th day of Christmas season, what I'm looking at then is what's the accumulative amount of sales revenue happened from the first day through the 10th day. So there's that adding up of the rectangles that comes through. If this was marginal revenue from the first day of Christmas season to the 10th day of Christmas season, let's go from the first day of Christmas to the 12th day of Christmas, okay, the 12 days of Christmas here. If I look at the accumulative amount of revenue that a store received, they'd have to go back and add up. What did I get on the first day? How much did I get on the second day? How much did I get on the third day, fourth day, fifth day, sixth day, up to 12 days? I'd have to add up all 12 of those amounts. If I use this approach, this is equivalent to going back and adding up all those numbers. Just like it's equivalent to adding up the areas of all those rectangles that we have here. Okay, so you've got a couple of things I want you to keep in mind. This notation, geometrically, is finding the area under the curve, finding the area of rectangles. Application-wise, it's the cumulative amount of a function over a period of time. So if this is marginal revenue, we're talking about the cumulative amount of revenue, because that's what the antiderivative is. Okay, well, hopefully that will come to you as we keep thinking about it. So let's look at this problem. This is just a typical problem we're going to look at. I've got it integrated from -1 to 0, and the integrand is x minus 2. Would you take your inspires, please? And let's get a visual on this first of all. So I'm like you, I need to get a new document probably, and I'll not save that, but let's go to a graph page. And let's put in x minus 2. Nice straight line. And our closed interval is from -1 to 0. So let's make a window change here, and let's make sure we include, let's see, we're going to go from -1, so let's make it -1.5. -1 to 0, so let's put in 1/2, and we can scale it by 1. And we shouldn't need too much output value space here. So if I put in -1 in there, I should get I'll put in a -3. Let's put in a 1, and we'll just scale it by 1. That should give us then what we need to look at. So let's see what we've got here. And we're going to scale this from -1, so right here is -1 to 0. I want to know what is the area that I'm outlining here on this surface, on this screen. So now I'm going to show you something that you can't use. This was not available when we get into Press the Test, but you can use it for practice here up to the final. Go to Menu and go to Analyze Graph and down to Integral. Again, this is, I'm almost positive this is disabled, this in Press the Test. Okay. Move the cursor over to about where you think -1 is on your input axis. Press Enter, and then as you move it to 0, look down at the bottom of your screen. Do you see a number? And when you think you're over at 0, go ahead and press enter. I'm going to bring that value up there. Did yours work that same way? Okay. So what we have now, we've shaded. We've shaded the region that we're looking for here, and it in fact even tells us what the area of that region is. So let's see if analytically we get the same answer. Okay, so we know that answer should be. Now don't take these answers as absolute. You know, if I'm off just a little bit on this point, I think I've got the point, but I move it, I'm off just a little bit, it's not going to be negative 2.5. And maybe yours didn't come out to be exactly negative 2.5. But it's a good estimate we can check our answer against. Okay, so here we go. What we're going to do, we have a problem that looks just like the fundamental theorem of calculus. So we're going to set it up in the same way. But before we can solve this problem, we've got to get the antiderivative. Now, do you remember how we get the antiderivative? First thing we do is change the exponent by doing what? Adding 1, and then we do what? Divide by the new exponent. Okay, so I'm going to put this in brackets. You'll see why in just a minute. But I'm going to say this is x to the 1 plus 1 power divide by 1 plus 1 minus 2 doesn't have any variable on it, but we can say it has it if we make it to the 0 power. Add 1, divide by the new exponent. What's missing? Plus c. Okay. I put that in a bracket or parentheses, so it doesn't make any difference which. But now you have to use, we're going to use a vertical line, and we're going to say it's from negative 1 to 0. We have to say it's that entire quantity that we're going to evaluate now from negative 1 to 0. What we've done is we've said this is f of x, the antiderivative, f of x from negative 1 to 0. It's another way of saying it. We found the antiderivative, and we understand that we've got to do something now to range it, to find it from the input of negative 1 to the input of 0. Now, if I've got the antiderivative, which is what this thing is in here, we can clean that up a little bit. And we would make it x squared divided by 2 minus 2x plus c. And again, that's ranging from negative 1 to 0. It's still f of x, the antiderivative. Now, if I want to put in, let's see, for me, b is 0 and a is negative 1. If I want to put 0 into the antiderivative, what does that look like? So I want to make this f of 0 minus f of negative 1. That's what the fundamental theorem of calculus says. I put the upper bound into the antiderivative and the lower bound, and I subtracted those. So I'd have here, now again, you've got to keep your parentheses or your brackets or something going, because if I put 0 in, let's see, that's 0 squared divided by 2 minus 2 times 0 plus c. All I'm doing is putting 0 in for the input. Minus, and I do the same thing, negative 1 squared divided by 2 minus 2 times negative 1 plus c. I put the negative 1 in as well. Tell me, please, what's going to happen with those c's? They cancel. And because they cancel, we don't even bother putting them in, okay? Because they will always cancel. We don't bother. Not necessary. They're always going to cancel each other out. Now, if it's an indefinite integral, do you have to put them in? Yes. Did we put them in, or at least think about putting them in here? Well, we did, but then we realized that it's always going to cancel, so we can't eliminate that. Okay. So let's see here. F of 0 is going to be 0. Everything cancels out. This is going to be negative 1 squared is 1, so that's 1/2, plus 2, and I am going to get negative 5/2 or negative 2.5. Is that the area that I got before? Yes. Now, let me explain something. If I'm going to go find the area of something, am I going to say I've got negative area? No. We think of it as absolute value, right? Either you have area or you don't have area. Well, why is this negative? There's a couple of reasons why, and this reason for this one is it's below the input axis. That's why. If it's below the input axis, it's always going to be a negative area. So what we often do, if we're just trying to find what is the area, we take the opposite of it. Okay? It's what we call the gross area, not the net area. And so the gross area would be 2.5, but it actually comes out to have a numerical value of negative 2.5. Okay. Well, let's take a look at this one. I don't know that this one is an example that was in the business or the Calc 1 book, and I don't think yours had anything equivalent, so let's practice again on how to do this. In order to do this problem correctly, I'm going to have to rewrite this. And I'm going to rewrite that as 2 fractions, and so I have x divided by 2. Would you allow me to make this denominator x to the 1/3 power? Same thing. Yeah, we want to do that. Okay, minus x squared divided by 2x to the 1/3 power, and dx. Okay, now that I've got it in this manner, I've got it, well, let's simplify just one more time. -8 to -1. This would be, let's see, I'm going to make this 1/2, and this would